Hey, Aaron, how you doing, sir?
I'm doing well, thanks. Hopefully, my internet holds out. I've been having some Wi-Fi issues all morning, and it's perfectly timed for when you have to give a presentation, isn't it?
It's what keeps us going, right? Oh yeah, that is a bit of a
Yeah,
lag.
fingers crossed.
Yeah, I was gonna say we do have a pretty significant lag. So let me bring your slides here, and let's get going and see if we have any more issues. You may want to shut off your camera
Hopefully not.
just to save some bandwidth.
That's probably a good idea.
Yeah.
Yeah, that might be a good one. So you can listen to the lovely sound of my voice, but not my audio. Oh, sorry,
No worries.
not my face. That's all right.
That's all right.
Now that's the button I wanted. Excellent.
Take
So
it away,
we're
sir.
now in audio mode only. Yeah, excellent. And fingers crossed that this goes a bit more smoothly than that little intro there, because I would think I was running at about 2 frames a second. Anyway, thanks for having me. I'm here to talk about Cosmos DB and F Sharp. My name's Aaron Powell. I'm someone who can't work out how to use a clicker in PowerPoint to navigate through slides, but you'd think I'd be better at that given that my job is a developer advocate at Microsoft. I've been doing web for kind of 15 plus years now. I have like all kinds of programming languages on the client and the server. I actually really enjoyed that last talk about Belize and Fable and compiling F Sharp to JavaScript, because as a web developer, I know just how painful JavaScript can be. I always look for how can we make it a little bit less painful. So I really like the direction of Fable, and I think it's a great tool. Also, if you want to get in touch with me after the session, if you got any questions or anything like that, you'll find my social media links and whatnot on the slide there. But you're not here to learn about me and how you can talk to me and stuff like that. You're actually here to learn about Cosmos DB and F Sharp. So I thought that before we get started into like the F Sharp specific section of the talk, I'll just make sure that everyone is familiar with Cosmos DB and basically get us all on the same page, because there's no point in talking about how we can use Cosmos DB with F Sharp if you don't actually know the role that Cosmos DB can play. So here is a quick rundown of Cosmos DB. Cosmos DB, it's a service inside of Azure that is designed as it's a non-relational database. So you can think of this as NoSQL, I guess, but it's a bit more nuanced than just what we tend to think of as a NoSQL database. It's designed for massive amount of geo-distribution. So whether you're working with data in a region, I'm in Australia. That's why the internet's so slow, because I'm a long way from everyone else. So whether you're doing geo-distributed data, you don't necessarily want to have to think about how you do replication and stuff like that. Cosmos gives you that out of the box. It's designed for that geo-distributed replicated data sets. And because of its NoSQL design, it's actually really well set up for that kind of approach. It's also designed for storing really large scale amounts of data. So whether you're building a small application, and we'll have a look at a couple of small demo applications today in this talk, or you're dealing with petabytes worth of data, Cosmos is designed to scale with your application for that. So you can start with it when you're only a small organization or solving a small problem, and it can grow with you without you having to redesign your data sets, redesign your database architecture, redesign how you work with databases. So with Cosmos DB, another thing that I really like about it is that we can work with it in multiple different ways. So while it is a NoSQL engine, it does have a SQL-like query interface. So we can use the SQL semantics that we're familiar with from Slate SQL-based data engines, selects, wheres, joins, and things like that. But instead of doing joins across multiple tables, we do joins with inside of a partition, and joins with inside of the data sets that we're working with. So a partition is and anyone that's a Cosmos DB fan that's watching the stream will probably like rock back in their chair and go, that's not what it means. But a partition is kind of analogous to a table. At least that's the way I like to think about it anyway. We put particular data structures into a partition. That helps with the way it's sharded and things like that. But it's then how we can access, optimize access for a particular data structure. So we can do that with a SQL query engine. And for the stuff that we're actually going to look from a demo standpoint, we'll use the SQL API. But you can actually use a bunch of different other database engines to connect to it. So if you're working with, like you're building an application and it's maybe porting from like a Mongo engine or something like that, you can actually use MongoDB's query language to query Cosmos DB. Or maybe you're building an application that a graph data model is a better suited approach. Well, you can use Gremlin for that. So you can actually model it with nodes and vertices and work with Gremlin to do graph-based queries against Cosmos DB. Or maybe you're working with more streaming data and something like that. So Cassandra might be a better option. So these are ways that it's all the same database that you're working with, but you can query with it different ways, and you just choose which engine you want to use when you set up the Cosmos DB instance, and that helps optimize for the style of storage and style of querying. We have SDKs in most of the common languages, whether you're doing .NET or JavaScript or Python or Java, etc. It's part of the Azure SDK, so you've got a bunch of different ways to query that, or you can go directly via the REST API. So it's really flexible and can be really adapted into pretty much any application model that you've got. And one thing that I really like is that it's got direct bindings with Azure Functions. We're going to have a look at that in a moment, but what this means is that if I'm building a serverless application and I want to store data in Cosmos DB, or just store data in general, I don't have to think about, well, how do I do connection management, particularly when you've got this dynamic scale out that we've got with Cosmos DB, so with serverless. I don't have to think about that sort of stuff. Azure Functions can just take care of that for me. We'll see that in a demo in a moment. But also, we can subscribe to change feeds. So when data changes within inside of Cosmos DB, let's say that we want to do something with that data. We want to make a view of it, or like remodel some data once it's inserted, or whatever that might be, pull it out for a reporting engine. Well, we can process that as a chain feed. Again, like to use a kind of a broken SQL analogy, this is sort of like having an insert trigger and stuff like that. So we can do that. And again, we can do that with inside of Azure Functions. So Azure Functions, I find this is like the easiest way to get into working with Cosmos DB and F#. I've got a blog post. I'm pretty sure I've got the link at the end about how we can get started with F# and Azure Functions, and how we can get started with F#, Azure Functions, and Cosmos DB. But as I said, we can do direct bindings for F# into Cosmos DB from Azure Functions, so we don't have to think about how we build our queries. We don't have to think about how we do connection management and all that sort of stuff. We just end up with the magic power of scalability through serverless. We can also use the change feeds from within inside of Azure Functions, so we can have our serverless applications triggered by what's happening when you insert data into Cosmos DB. But that's enough slides for a minute. Let's jump over and have a look at how we can use F#, Cosmos DB, and Azure Functions together. Now, you don't have to forgive me, I also got a new keyboard this week. It's a very different keyboard layout to what I'm used to. So you're going to see a lot of very slow typing as I try and remember exactly where every single key I need is. There we go. Okay, so this is the VS Code instance that I was actually looking for. I've got multiple of them open. This is an application, interestingly enough, it's actually using Feliz. So it was good following on from that last talk, and like I said, I really enjoyed that kind of stuff. So this is an application. It's got a React or Feliz front end, compiled to React that runs in the browser with an Azure Functions backend. So a very serverless web application. We can have a look at this application. It's a trivia game. We can start a new game. And so this is then hitting Azure Functions, and we're going through a whole bunch of different steps. So let's do a trivia game. We'll join as me. And then it's going to ask a bunch of questions that will submit the data through to our server. I won't go through and actually play the game. There's a link to this blog post at the end, so you can have a look and play with the code and actually run the application yourself. We're not interested in how the game works. We're interested in how the code that makes that happen exists. So inside of VS Code, I've got a bunch of Azure Functions written here. We'll start with create game. So this is, and let's just move the sidebar off there, so we've got a bit more space for code. So this is an Azure function. It's bound to a HTTP trigger. So that's indicated here. So this is going to accept an incoming web request. But then we have a Cosmos DB trigger. I'm saying that I want to connect to a database called Trivia with a container called Game in my Cosmos DB instance using this particular connection string. Here is the SQL query. Oh, and one thing about the Azure Functions support for Cosmos DB is you must use the SQL query language. It doesn't support Mongo or anything like that because it can only understand one approach. So we have a SQL query here. So I'm just selecting ID from blah, blah, blah. And then we're binding that as an anonymous record sequence. So that's the output that we're going to get. So now, like, there's nothing here that is tying us to Cosmos DB. We're working with just F# primitives. If I want to write some data back out, I have an outref of a record type that I've got inside my application. We'll see that that game, if I can find that one, that is in my shared code with the client and the server. We'll see that game is just a record type that I've got here with just standard .NET primitives. So then we get back our sequence of question IDs. We're going to scramble them. We've just got a little function that randomizes them so we don't get the same 10 questions every time. And then we're going to pop out the IDs, create a new record, put that into the outref, and then we're going to return an object result. So here we're working with Cosmos DB. This is something that, how did we connect? I don't really know. Like, the connection was handled by Azure Functions. We had a SQL query that we initially wrote, but we don't have to think much more about it than that is being mapped into an object model. If we wanted to do something maybe a bit more complex, or add a player to a game. So here we've now got a couple of input bindings, which are stretching the ability of my screen to show this very zoomed in code. We've got a couple of input bindings of Cosmos DB. We're getting a sequence of existing players, but you'll notice that I'm also taking in some parameters from the URL that's been passed. So this URL has a bunch of parameter segments, game ID and name. So we're putting that player into that game, and we can then inject that into the SQL query that's been called for Azure Functions. We don't have to we don't have to write that query ourselves. Azure Functions will take care of that for us, and then gives us back a sequence of player objects, which again is just a record type that we've got. And then we've got some more outrefs to write data back out. And then it's just standard F# code working with F# primitives. And lastly, let's say that we were doing something that did require some async operations. We've done everything synchronously so far, but if we were doing something asynchronously, like maybe we had to read the body of the request that's come in to unpack that as JSON, we can do that. So again, we've got a Cosmos DB binding here where we're getting back a game. And this time I want a game based off of its ID. So I don't have to write a SQL query. I can just tell the Cosmos binding for Azure Functions, I want that ID. Here's the game ID. It's going to come in as a URL segment. Just give me that game. Done. No SQL queries written, no connection management. It just no worrying about how do I extract an ID out of a URL. It's just bound for us. And then this is going to need to use, we're using an async block here because we're doing an async operation. We're reading out the stream. We're reading that to the end and unpacking that as JSON. So because this is async, we can't use an outref. Instead, we use an iasync collector. So here is, it's an asynchronous collection where we can push items in and we can do multiple add events, which unfortunately this returns a task, a non-generic task. So we have to just kind of ignore that result. But creating a new record, pushing it in, that writes it across to Cosmos DB. And again, I haven't had to think of what is the insert or update or anything like that statements that I might have to write for working with Cosmos DB. I'm just working with .NET objects and strongly typed objects. So that's how we can work with Azure Functions and Cosmos DB. As I said, I'll put a link to this code sample at the end if you want to have a bit more of an explore of it. But not every application is going to be applicable for working with serverless. So what do we do if we're working with just the Cosmos DB SDK that we get, just the standard one for working with SQL operations? Well, let's have a look at this code sample. So this is the Azure SDK for Cosmos DB, and here's how we can get back an item or a series of items from a parameterized query. We create a query definition, we pass it through a SQL statement, we're adding a parameter to it, and then we're using an await for each because this is giving us an iasync enumerable back that we have to iterate over. Now, from a C# standpoint, this is fairly expressive code. This is what we're familiar with from writing C#. But from F#, it's it's a little bit more cumbersome. We don't really have this await for each in F# because, well, the notion of a for each loop is not really something that's happening with inside of F#. We would tend to use the appropriate iterative functions off the collection type that we're working with. And also, like when we're calling the with parameter section on the query definition, are we mutating the existing query definition, or are we creating a new query definition? So there's a bit of opacity, at least from my standpoint, of what's happening here, particularly when we're looking at it from an F# lens of how we would tend to work with expressive code. This it works, we can do it, but it doesn't feel quite right. So how can we make this feel a bit more like F#, and how can we make this work in a more F# expressive manner? So time for another demo and for me to work out where Alt-Tab is on my keyboard. All right, so here is another example application. Again, this is working with that same trivia database backend. And this is, I'm going to walk through the fundamentals of this code, but this is a code base that I actually presented for Cosmos DB conference earlier in the year. So you can go back and actually watch that presentation if you want to see how we can build this whole application throughout the course of that talk. But what we've got, again, just standard record types. We're not having to create classes or anything like that, but we're importing a new namespace, which is f#.cosmosdb. So this is an open source project that I created for making it easy to work with Cosmos DB from F#. Now we need to tell our record, or annotate our record type in two ways so that we can work better with it. We need to tell what field of that record type is going to be the ID field, so the unique identifier for our records that go into Cosmos DB. And the other is the partition key. How are we slicing and dicing the data that goes in? So we have two attributes that we put onto our members with inside of our record types, and that's what we end up with here. So we end up with a partition key. So question has ID and model type is the partition, and similar for game is somewhere inside of here. I have a type that represents that as well somewhere. Now, when we go ahead and create connections and stuff like that with the Cosmos DB SDK, we need to create a Cosmos connection, and then we connect to the data, we get the database back from that, and then finally we can get a container so that we can query against a specific set of the data with inside of that database, inside of that Cosmos DB instance. And this is, again, it's cumbersome. It's using chaining style operators, so chaining method calls in C#, which is, again, I'm not saying that that's a bad pattern or anything like that, but that's very familiar from a C# standpoint, but it doesn't really translate as nicely to F#. So the library that I've created, I've introduced more of an F# idiomatic approach where we go Cosmos DB from connection string. So we take a connection string, and then this gives us something that we can pipe forward into the other methods. So we can do cosmos.database. What's the database name? And then we're going to take that connection that was established, and then we can pass that database into our Cosmos container. So this is the same as if we were doing Cosmos connection.getDatabase.getContainer. This then gives us a connection operation that we can pass into, say, where we want to perform a query. So we're doing a cosmos.query. We're giving it a SQL statement query that we're executing. And again, this we can pipe into our connection operation. And then if we come down a little bit further and have a look at how we can use that, we'll skip over the boilerplate code for setting up local config and things like that. And the other thing is this is then going to use the F# async model for doing asynchronous programming rather than the task stack that is what the Cosmos DB SDK will actually use under the hood. But we can establish a connection from our connection string. We can then get a game by calling get connections, which is the function that we had just before for performing the SQL operation. We're going to execute that asynchronously and then strongly type it as a question. And then this gives us back an async seek, because under the hood, this is an async enumerable, which we can translate to an asynchronous sequence inside of F#. So we use async seek, we get that back here. And then this is, we're folding over that. So we're folding over each question and playing the game that way. Finally, we get back our game record, which we can then pass to Cosmos insert. Again, we execute that asynchronously, and then I'm just async iterating over that, outputting just a printfn statement, and then we complete our application. So let's have a look at this one in action. So we'll do a .NET run. Give this a moment to start up. Drum roll, please. There we go. So this has gone, it's pulled back a bunch of questions from Cosmos DB. It's popped them up. Unfortunately, it hasn't taken care of HTML encoding and unescaping those. So we have the less than and greater thans and things like that. But yeah, so this is now a series of questions that we can go through and answer. And yeah, bang, ta-da, and we have a console application that's playing that same game that we just had playing with inside of the browser. Not interested in seeing how the game actually plays out, and also I don't want to get a question wrong when it's on stream and have forever that recorded of the fact that I should have known the answers to the questions that I have in my own data set. And okay, so that's really good, and I think this makes it a lot nicer to work with common operations inside of Cosmos DB. Like we're querying for data, performing inserts, deleting data, and things like that. But one thing that I love about the F# ecosystem is just how much work has gone into making the tooling really optimized for the sorts of things that we're doing in F#. I'm going to jump through to the final VS Code instance that I've got open here. So this is actually the source code for the Cosmos DB wrapper that I've created. And if we come into the program here, we'll see a bit more of what we can do. We can perform inserts. We can get back individual items. We can perform updates. And all of these are just written as little functions that I've got here with inside of my F# application, queries, etc. But it looks like that we've got some little red squigglies appearing up here. Let's jump up to that. So we'll start with the red squigglies. One thing about writing SQL statements or like any kind of database query statements like this is, well, you kind of don't know until runtime whether or not you've got them correct. Well, that's where we can take advantage of the F# analyzers that we have with Ionide. So I'm using Ionide inside of VS Code, and analyzers can give us some insights. So if I hover over this, I always forget that when you're creating a parameter to pass through to an F#, through to a Cosmos DB query for a parameterized value into the SQL statement, we have to prefix it with @ All right, well, it's telling me that, well, I need to have an @ symbol in there. So let's put an @ in. And then it's telling me the same for last name, so we can add that in. Cool. But now it's saying, well, hang on a sec, we've got age, but it's been defined as a parameter, but we've never used it. It turns out that I've written age with all caps. So we can change that, and then there goes that squiggly. Similarly, last name, that should have been name. And then that will get rid of those squigglies. Even up here, it's detected that I have a connection string inside of my app.settings.development.json file. It's tried to connect to that database, that Cosmos DB instance, and gone, well, hang on a sec, the database that you've got there, well, that wasn't found. And then because that wasn't found, there was no container found for that. So, well, it should have been family. So we'll go family, update that, and then that will get rid of that squiggly. And these are the sorts of things that you wouldn't detect until runtime. For some reason, it's not giving me quick fixes. It should have quick fixes, so I could do Control Dot and would list out all the containers and all the databases and things like that, so you could select from them. But I'm not quite sure why the quick fixes have stopped working. That's a problem that I'm going to have to deal with after this talk. But yeah, the idea is that you could just do Control Dot, enter, and quickly add that back in, which I think this sort of stuff, it's runtime, it's detecting things that you would probably have runtime errors if you didn't realize that they were there. Well, I think we're nearly out of time. So let's just kind of wrap up with a couple of links that I think could be useful. As I said, I had some of those demos. You can go check those out afterwards. If you want to learn a bit more about using F#, Azure Functions, and Cosmos DB together, I've written a blog post on that. I'll post these links on my Twitter feed after the fact, or you can use the QR codes that I put on the slides to scan them. Mostly the blog URLs were really long, so I didn't want to try and put them in there and someone's madly typing them down and I've gone to the next slide and you've missed it. So use the QR code or check out my Twitter feed shortly. And if you want to check out that that trivia application that runs in the browser, you can check that out on my GitHub. And that has a link to the blog post and to the live stream where we went through that in a bit more details. And as for working with F# and the Cosmos DB SDK, so if you're doing a non-serverless application, you'll find the source code for that at on my GitHub, aaronpower.com, github.com/aaronpower/F# Cosmos DB. Again, QR codes. And if you want to check out the Cosmos DB console application that works with the F#, works with F# and the F#.CosmosDB wrapper library, you can check that out as well on my GitHub, and that has a link. Well, at least I think it has a link to the talk that I gave at F# at Cosmos DB conference. If not, I will quickly go and fix that while you're manually writing down or waiting for me to post these links on Twitter. But as I said, I think we're just about out of time. So thanks everyone for having me to show you a bit of why I think Cosmos DB and F# are a great match for building applications. And I think there's a lot of value you can get out of those, and I think that they can work really nicely together, whether you're building a serverless application or working with the Azure SDK, and even if you're using my little wrapper library to make it a bit more F# friendly. Thanks for having me. Feel free to shout out with any questions or ping me on social media, email, etc. if you want to ask anything I don't get to cover off when my Wi-Fi invariably fails in a few minutes.
It's all good. Like I said, it's the joys of doing conference talks. So thank you, Aaron. Oh, perfect. There you are, sir.
I'll stop my screen share because that should give me a little bit of space back. Oh, and sorry, I forgot to finish.
Such a perfect job. Thank you so much again, sir, for doing the presentation.
Can't hear an audience, so you better bring your own.
That's right. All right. Well, we have Beth and Alan coming up next, so I'm going to do this little change here of speakers. So I'll see you later, sir. Thank you so much.